Record to the cloud. Okay, we are recording this message. This is a special edition of the Aries working group meeting. This is about the Aries Cloud Agent Python architectural deep dive. I am the mouthpiece for this, but we do have Nick and Andrew and Stephen Klump on the call who have all contributed, as have others, to the code. So they'll fill in any details. I'll just talk through all the pieces. Feel free to jump in with questions, raise your hand. I've got the participant list up so I can see that, or just jump in and ask questions and so on as we go. Whoops. There we go. Got to have this up there. This is a Linux Foundation meeting, so code of conduct applies. If you haven't taken a look at it there. Otherwise, or as well, the antitrust policy applies, and it is written there. So the goal of this introduction is to first start with the Aries Cloud Agent controller developers. So controller developers, people that want to simply use the Aries Cloud Agent Python will know what to do. So cover that first, and then as well deeper dive in for developers interested in digging into the agent code itself. So we will be looking at how the code is organized, pieces of the code, and other things that developers would be interested in. So there's an overall agenda. Bunch of stuff to cover, so we'll go through it, you know, piece by piece and sort of introduce it as we go. And as I say, all the developers that I believe have made contributions are on the call, so feel free to ask questions. Overall architecture is this picture here. Again, it's basically two parts, and I think you can see my mouse as I circle around. Yep. Okay. The agent itself is basically intended to be, you know, managed in ACA-Py and deployed as is. So for a controller developer, you would not need to delve into the Aries Cloud Agent itself. The Cloud Agent connects, obviously, to ledgers out in the internet and to other agents out in the world. And then in the back end, there is a second component called the controller. The controller contains the business logic for an instance of the agent. So there's basically two parts of every implementation. There is the agent, and then there is the controller. The agent, as I say, is intended to be deployed as a unit and pulled down. It's configured via command line parameters, and we'll go into a bunch of those and how that works and a bunch of them. Interacts with other agents via pluggable transport, currently supported HTTP and WebSockets. Manages storage, manages ledger interactions as well with pluggable implementations. Has a series of protocols embedded in it. The protocols are externally, it can be externally configured, so you can actually have an agent that you pull in from ACA-Py, but as you deploy it, you bring in other protocols. Those protocols fire events at the controller via HTTP calls and receive back via a REST API, an administrative API to receive requests from the controller. And basically, that's how the controller manages the agent. It receives events from the agent based on things that happen in the protocols, and then fires requests via the REST API, the HTTP JSON API, to the protocols to tell them what to do. So for example, if an invitation comes in, the protocol would say, hey, controller, I got an invitation. What do you want me to do with it? And the controller would send a message back saying, hey, accept that invitation. And the agent would then do that. and then that would cause some other events to occur, and you know, the protocol would occur with the other agent. The other agent might reply, send an event over to the controller, who would then decide what to do with that event. And that's basically the flow. Obviously, as well, the controller can say, hey, I want you to send an invitation out. And that would be initiating an action via the API. It does say REST API over here. I've generally called it an HTTP JSON administrative API, in that it's really not REST. It is just using HTTP JSON. I mean, arguably similar, but it's not, definitely not pure REST in that case. That's the overall architecture. For those who just wanted that, you know, we're done. But anyway, that's the start of it. Any questions at this point? And also from Nick, Andrew, did I screw anything up?
Stephen, I want to jump in for a second.
Yeah.
So this is John Jordan speaking. I've been, I guess, leading this project for the last 3 years. And I just want to emphasize that, the great work that the team has done, you know, with our collaboration with Government of Canada, Mr. Klump and Nick and Andrew and all the team. But just want everybody to understand that this is a second generation agent. This is based on a year and a half of hard work, understanding indie and working, you know, within the indie community with Sam and Nathan and all those folks. So just want people to understand that this is designed from scratch since January of this year to be a cloud native, highly scalable, easy to use cloud agent. It's my advertising.
Cool. That is true. This was literally, we implemented OrgBook, or the team implemented OrgBook with issuers and agents, and we threw all that code away and started basically from scratch, reusing what we could, but the design is definitely from scratch. Okay.
Hey, Steve, can you spend just another couple seconds on the Pluggable API or the protocols? Is that something that is going to be like built in and just configured, or did you say that these things can be dynamically added?
These can be dynamically added. We'll get to that in a bit, but basically there's a command line parameter that basically says, hey, I want to include these protocols, and that would add more protocols. And with each protocol, you're also extending the API available to the business, to the controller. So we'll get to those, but yes, that is how they work. Is you can add more as you want, and they're implemented as Python modules.
Great, thanks.
Okay. There is a pile of documentation out there, so I've got links throughout this presentation, and I should probably send out the presentation. People probably want to access it, so maybe I'll take a second to grab the copy the link. Sorry about this. I should have done this first, and I imagine somebody's asked for it in the chat, so I'll add it to the chat right now. There's a bunch of messages in the chat. Will the slides be posted somewhere? You bet, and we'll put them in the Aries channel. But there they are. There are the slides. Okay, back to the presentation. Documentation, there's a pile of links in this. For example, here is the main README. That's fairly simple. Yeah, the Aries Cloud Agent documentation. The developer README. I lost my full screen, so I'll go back to that. I won't pull them all. A developer README is a much more traditional GitHub README that just says, you know, here's how to run it, here's how to run tests, or here's how to write tests for it, links to the contributor guide and things like that. We as a team have written, as a group, written a fairly extensive getting started guide, which is intended to be from, my boss wants me to do something with Indie and I don't really know what Indie is, I've heard of it, right through some of the deeper components of the guide, or sorry, of Aries and DIDCOM. So that's all covered in a getting started guide. There's a series of demos, so there's a /demos directory. There's basically 5 exercises that we've got it. One is IAW book, which is a demo we've done for a number of people, and probably lots have seen it, but it's a mobile agent that was implemented by StreetCred, interacting with a couple of ACA-Py Aries Cloud Agent, ACA-Py services. So you can run that. There's a command line version of the demo. There's actually a Swagger Open API demo. There's a cool demo of running a performance test with it. So you can issue 300 credentials and see how long that takes and see where it takes its time. That demo can also be run. We'll show that as well, or, I'll show you how to do that, or actually it's covered in the demo guide, is running the performance demo, but with a routing agent in between. So the first one, you've just got Alice and Faber. In the second one, you've got Alice's routing agent and Faber, and the messages are forwarded, all messages are forwarded through the routing agent for the demo. And finally, there's a demo where we extend Alice and Faber to include Acme. Alice goes looking for a job and needs her Faber credential to apply to it. And this one is such that you add the code necessary to implement the controller. All of these are more or less focused on the controller part of it, implementing the controller and using ACA-Py as is. Coming soon, read the docs. We have it generating, but it's just producing a laundry list right now, and we want to clean up that a little, so adding that. So that's documentation. Deployment, as I said earlier, there's a whole pile of command lines. They are documented all, and we'll continue to update that. They are documented here in the developer README. So there's a whole series of them, and I'll cover a few of them in the next slide. But things like what inbound transports do you want to, or what inbound transports do you want to use? What outbound transports do you want to use? You could actually have multiple of these, and things like that. So lots of options for it. Intention is that you basically would, as you come up with your use case of how you want to deploy it, a lot of the configuration is done by simply how you invoke the agent. So for example, the demos use a set of parameters that define specific behavior for handling invitations and credential exchange. In the process, for example, the agents are configured to automatically accept invitations and automatically accept credential offers. So that reduces the effort you have to do as a controller. So you can push some of the standard functionality that you would want to do simply by implementing or using command line parameters. If you want to add more command line parameters to automate that into the, contribute that into the system. And that will handle some of the duties the controller might have to do based on your use case. We've written wrapper scripts that allow you to pass in parameters at deployment time. Docker would normally, Docker, if you're doing, some more production ones like OpenShift or Docker, those would be set up as the way you configure the agent for use. Lots of parameters. These are the categories of them. So as I mentioned, transports, how you handle logging and debugging. We're going to do a demo later of how you would run add a debug parameter so that you can interact from an IDE, from Visual Studio Code, and debug an application that's using the agent. Wallet implementation. So if you want to use a base wallet or a SQLite or Postgres, so how you want to handle the wallet. Certain Indy ledger parameters. Right now, this agent is very Indy focused. We want to get another implementation with another ledger and verifiable credential process in, but right now it's fairly Indy specific, and so these are things like how you handle the Genesis file and where that's found. There is security on the API. So on the admin API. So there's two things there: is what is the URL you want to use for your admin API, and then security selection. You have to explicitly choose to be either insecure, have the API be insecure, or pass a token in, specify a token that must be used on all API requests.
So to clarify, the intention is not that you would run it insecure, it's that the software itself would not provide the security, and you would provide security through network configuration or other means.
Correct. So basically you would say, oh, I'm in development, I want to use the --admin insecure. And then when you go to deploy it in production, you would say, well, I would not want to run it insecure. I would never do that. So I'm going to add my own security in that way. So at minimum, you would have to use a token. You could also configure it in some other way to secure the interface so that nobody could get it from outside. And we are thinking of other ways we can extend that model so that it can be even more secure by default.
And that's the agent admin API that has the security on it, not the controller.
Exactly. Yes, the API from the agent side of it, what the controller is talking to. Alexis has a question, hand raised. Go ahead.
Yeah, so correct me if I'm wrong, but this is a future, more polished iteration of what was IndyCat, right?
Yeah, so we originally called it IndyCat, and it's now been renamed, and it is the same implementation, just taken 3 weeks further.
All right, and so when I was using IndyCat, I noticed when you use it in a production environment versus a testing environment, the API calls are slightly different. Is that still the case for this iteration? I'm just wondering.
It shouldn't be any different. So the only thing there is how you want to pass parameters to the admin API to configure it. I'm not aware of any difference between how you would deploy it production versus developer. The calls are different. Any more details on that? And maybe Nick, you can jump in.
They should be the same. I'm not really sure what you're referring to, Alexis, when they were different. But in this in this iteration, they should be the same.
Yeah. No, I was just wondering because I remember when I was using IndyCat, when I deployed it on an AWS server, it was just the flow of credentialing was slightly different on the API call versus when I deployed it locally. But that's all. I was just wondering if it's the exact same, then shouldn't change that much.
Yeah, it's certainly intended to be. There's not supposed to be any difference.
All right, awesome. Thank you.
Okay. A couple of things to underline here. Here's some of the examples of the automation flags, optional protocols to load. So that references what was talked about earlier, that there's a literal parameter on the command line to say, I want to load this protocol, and you can have as many of those as you want. So you can load additional protocols at runtime. And then finally, the event webhook URL. So this is what the controller exposes to enable webhooks to fire into the controller from the agent. So this side is from the controller to the agent. The event webhook is the other way around.
Will you be covering the various webhook URL configuration options in like there's one in the command line, but like in the demos and stuff, because there's different ways to configure that?
I'll certainly show where we're configuring the command line in the demos. I'm not sure specifically what more that is.
Okay, yeah, just options for configuring the webhook. Okay.
Okay, yeah. Added this future direction. This is something that Andrew's working on right now, which is to make it more Git or Docker style command line. So you run ACA-Py command, and then you'll have major subcommands like run and wallet and ledger that will allow you to do those interactions, and those will kind of persist in the context of where you are. And so that way you can have sort of a command line set up, create a wallet, configure a wallet, then run the agent. And so that can separate some of and reduce the number of, when you're in production, you can run the wallet setup one time, and then from then on, run the agent without having to specify all of the wallet related parameters every time you run it. And that will lead to information hiding, basically. You can configure the wallet, tell it, for example, what the Postgres admin API is necessary to create the wallet, and then not have to specify that when you go to run the wallet from then on. So that's kind of future direction, which is next couple of weeks. So that's parameters. Go ahead.
So I have a question about that. Is there any current thought into passing a config file instead of parameters? I asked that question hesitantly because the prior stuff you mentioned, where you have commands to do the configuration may substantially reduce the command line argument load as it is anyway. So maybe it won't matter as much.
Yeah, Andrew, do you want to touch that? Hit that one. Is Andrew there? There he is.
Well, no concrete plans at the moment, actually. Have to decide on a file format we like. Still kind of developing the command line interface, so then we'll see how that maps really.
Okay, thanks.
I mean, this is the next thing we're working on, which is this major command and then subcommands, or subcommands and then parameters on those. After that, we'll take a look. Sam Smith, your hand is up. And it's not anymore. All good. Okay, next one. Let's see. Controller events and administrative API. I think I've talked about this a fair amount. I've got a bunch of links here. So again, listens on a webhook URL, processes the event, optionally passes to an external system. So an external system might be a person, might be a legacy system, whatever it is that comes up with the rules to decide what is the next step. How do you want to respond to this event that you just received? And then optionally responds with an HTTP request. I mean, obviously the controller may pass hey, what do you want to do with this to a legacy system, and then hear back from that legacy system, 2 days later on how to actually respond to the request originally. So if it goes to a person, it could go into their queue and wait till they respond to it much, much later. So that is one way that events get processed. And then take inputs from other sources. Those could be, again, legacy systems, persons either they finally get back to you on that event that occurred earlier, or you want to initiate a new event, like the legacy system publishes credentials to be printed on the wall, and from now whenever they publish or print a credential, they also send it over to be issued to an org book or something like that. And so that could be an event that occurs from another source. Input is processed, and then optionally agent protocols are initiated to the administrative API. So that could be how your agent initiates requests. The Alice Faber command line example is pretty simple. It's simple in that both agents more or less know about each other. I'll provide a bunch of links in here, and this is basically a roadmap for the demo code. And so that's what I wanted to show. So an agent is deployed as a sub-process. We actually have a ticket out that I think is being grabbed to implement the controller and the agent as entirely different processes. So we would actually have two Docker containers, one with the agent, one with the controller. But right now, the agent is deployed as a sub-process of the controller. So we go into here, and hopefully you can see that. Maybe I can zoom a little and make it a little bigger. So basically within the agent.py, so the demo code directory, I'm highlighting that at the top, has a runners folder in it. And then below that, runners is where Alice and .py and Faber.py are. Then below that is agent.py, which is the base class of Faber and Alice. And so within that, we've got the process. And within the process, we get arguments to run, and we start the process. Sam, you want to go ahead?
Yeah, the events that the agent sends to the webhook URL to the controller, are those, is there a predefined set, or how do you define what events?
The events are, we'll cover this a little bit later, but basically within the protocol, everything that is a state change triggers an event, and it bundles up the state of that protocol. So you know what instance of the protocol is running, and then the state of the protocol at the time you were called, and then you get handed the event. So you get handed the data structure.
Oh, okay, so for a given protocol, where are the state change events defined?
Those are largely, should be defined in the, here's where we get a crossover between specification and implementation. So the Aries RFC do define, are intended to define all of the state transitions. Those are done in a human form. The code for the protocol implements where the transitions occur from a code form, from an implementation form. So at some point, you know, we're gonna, I hope we get into more automated, more machine-defined specifications for what a state object looks like, for example, and what are the set of state events that occur. But right now, it's more or less understand the RFC for that protocol, and then probably look at the code to see what events get passed to it.
That sounds
Nick,
like a good
Andrew,
place
any comments?
for auto documentation generation by documenting each method that results in an event, so that you read the docs will just automatically pick those up.
Yeah. And Nick, you were going to say?
Yeah, that would be ideal. Right now, inside of the messaging module, each of the message directories there, so these are all sort of mapped to different protocols, and you can look inside, and each of those directories will have a models directory, and then so that you have inside the models there, if there's a state for the the transitions of that protocol, or a model for those transitions, then that would live in there. And usually it's like for connection, it's connection_record. For credentials, it's credential_exchange. So it's, yeah, so there you go. So it's not, it's, I think there's some work that can be done to make it a little more consistent. It's pretty consistent now, but it would be nice to get to a place where it's, like Stephen mentioned, like machine defined or very, very consistent.
We'll also show a little later what the Swagger API gives to you, because now you can see how you get to respond to it. And it largely defines a lot of these states. So we'll show that in a bit. Let's see, what else was I going to show in here? So initializes. Let's go back to this. So deploys an agent at a subprocess. So I had a link to where the process is actually defined. Then it initializes the agent. So in this case, I'm in the Faber agent. The Faber agent creates a schema. So what it does when it starts up, so those not familiar with the Alice Faber, Faber is the college whose logo is, or whose motto is knowledge is good, which is why we're here. It spins up an agent, it creates a schema, and then that has name, date, and degree, as you can see here. So it creates a schema, and then it creates a credential def, which is here, and then it finally generates an invitation and waits at the command line. So it generates an invitation for others to connect to it, and Alice is going to use that. Waits at the command line, again, that's basically where it sits. After it does that, it sits here at a command line. And so when I talked about in the example of takes input at other sources, so now basically Faber is sitting available to do two things. One is it's sitting at a command line waiting for you to type 1, 2, 3, or X. And as well, it could receive an event from Alice that is her processing of the invitation that has been posted and sending back a request connection in reply to that invitation. So that really encapsulates, you know, the loop, the wait loop of Faber.py or any controller, which is you're waiting for input from protocols that either others will initiate or are in flight, or you're waiting for input from your business process, and your business process wants you to do something. Whoops. Initiates protocol invocations. So let's see where this takes us. So in this case, from the command line, a 1 was entered by the user. A 1 means issue a credential to whomever that is on the connection, in this case, Alice. And so in this case, of course, we don't go look up in the database of all students and find Alice and find her records. We just make them up on the fly and hard code them. So there's Alice's grades and age and her degree. And then we post them to the API. It's as simple as that. So this is the HTTP post to /credential exchange /send offer. And that triggers the send offer processing. Recall that in the parameters, we can set things like automatically process them. So Alice is set to automatically process the offer, send it back. And Faber is automatically configured to, once a request comes back, to actually issue the credential. Those could all be individual events, or they could be set up as they are in this to automatically be processed by the agent. So the controller doesn't have to be bothered with the nitty-gritty details of the protocol in that case. If they want to be bothered by the nitty-gritty details, they absolutely can be. Does that make sense? And this is listen for, so that was protocol invocations. Here is, let's see where this takes us. So this is in the Agent PY, where we're basically listening to the webhooks. This is saying, here's where we're listening. We're running in a couple of different modes. We've actually set it up to handle different things, specifically in how this demo is getting used. We'll talk about this one later, but basically it's just listening on a URL. We process events. So we got a request. It came from the agent into the controller, and the event was handle credentials. The event was actually credentials, and there is a handle underscore event throughout, and so that's what gets invoked if that exists. And so here's the processing that the agent does. In this case, Alice does when handed a credential. So it finds the credential exchange ID, it finds the state of it, logs it, and then change the offer to the state to offer received, and posts a send request to get that credential back. So in this case, we're doing fairly complete processing in the controller to request the credential. So that's the idea of how those all work. Again, Sam mentioned this, and here's the link to where that is. In this case, when we run the get arguments, we process all of the parameters here. So this is the setting of the various parameters that are used in the demo. So this is one way to set the agent parameters so that when we invoke the process, all of the parameters are going to be set the way we want them. And we can do things like optional setting up storage to be Postgres and things like that. Okay.
Quick question.
Yeah.
How are the keys stored for the agent to sign the responses?
So the main key you've got to worry about in this case is the wallet key, and those are handled through a series of command line parameters or environment variables, and those would be done and handled in your production environment as would be appropriate. The keys within, you know, for a particular connection, for a DIDCOM connection, or if posted to a ledger, those keys are handled in different. The DIDCOM ones are all handled more or less automatically. The ledger one, so if you need to create a ledger, you would either, for creating a DID on the fly, you can pass in a seed, you can pass in a wallet that already has one in it. So there's various ways of handling that in both development scenarios and in production scenarios where you need that security.
But now there's some kind of wallet abstraction that's used, and that can then be linked to, you know, a something simple for a demo or something more elaborate for a production system.
Exactly.
Is that
okay. So right now in our production systems, we use OpenShift, and we're using OpenShift secrets to inject those type of secret, you know, parameters at runtime. We're going to be shifting later in the year to use Hashimoto Vault. So Vault will be our container for those crucial secrets for these, and we would create an integration with that so that we can, at deploy time, be able to get the secrets necessary without exposing them in any way. But that is basically exercise left to the reader as the best way to secure your application.
Okay, thanks.
So your production controller repo. So just some guidelines on what you do. Contains the code for a controller. Your production controller repo contains your code for your controller. Generally, it's created from scratch or copied, but not forked from an existing implementation. Basically, think of this kind of like, oh, we're building on Django. You don't fork Django or fork a database or an instance that uses it. You might copy one as a starting point, but that's the way you create a controller repo. Again, underlining, do not fork the Aries Cloud Agent Python as the basis of your controller. Pull it in and deploy it. Our recommendation is that you pick a tag, a release of Aries Cloud Agent Python to use, and subscribe to the repo for release notifications, and continuously upgrade and follow the released versions of the agent. We're not a fan of using master as the basis for your agent. You're more than welcome to do it. We just don't think it's a good idea. And just follow along with as the release notifications come out. So that's how you would get a controller one. Here's a couple of examples. In the email verification, this is used, and IIW book are both used in the IIW demo we did back in March, and they have been updated to follow along with the releases of Aries Cloud Agent Python. So they now have the latest releases in there. Okay, so that's controller. Hopefully we're moving along. Controller events, we've talked about this. It's basically what Sam was touching on. Internal state is maintained for all the protocols. Every time a transition occurs, the representation is serialized and sent over to the webhook. Currently, it's all state transitions. You just basically register a webhook and it's used. The controller can use the data in the state transitions. You know, use it as you need to. If you need to maintain state on the controller side, which is absolutely likely, you would persist that in whatever way your controller makes sense in your controller.
I have a question.
Yeah.
So you showed in the agent a place where it's listening on the webhook URL, which kind of confused me because I thought you're posting to the webhook URL. So other than listening for, like, you know, an HTTP OK response or something to a post, what are you listening? What is the agent listening for in that?
No, that was the controller. That was the controller.
Oh, that was the controller. Okay.
Yeah, that was the controller listening to the events from the agent.
From the agent. Okay, I got confused.
Yeah. Okay. Again, I think I've mentioned all of the things here. Administrative API. Again, underlying each protocol adds API events, and externally loaded protocols can also add their own admin API. So you basically have this dynamic Swagger API that grows, and as you add protocols, it becomes a bigger and bigger list of methods that can be called, requests that can be made by the API. So now we get a bit more into the agent itself. So as we say, the controller stuff is important. Now we get into that.
Before I switch out of that, I have one question.
Yeah.
The architecture assumes a one-to-one relationship between controller and agent, right? You wouldn't, it's not in the design to have two controllers that connect to the same agent?
That is correct.
That's correct. I should underline that both are horizontally scalable, though.
Yes, yes. But for example, if you want to implement like two controllers for separation of concerns, that's not really in the design. You would need to do that behind the controller interface that you develop.
Yeah, and if I can just touch on that really briefly, the intent there is that if you want to run a sort of agency, as they're called, so kind of the multi-tenant agency, the intent there with this architecture is that that's kind of a composition of multiple agents. So you could have, say, 3 agents that all correspond one-to-one to a controller, to each, 3 different controllers, and then you could have a 4th agent as a routing agent out front. And so the intent there is to compose multiple agents to create that sort of agency, which is a construct in the Aries world.
Cool. Okay, we're got to keep moving along. We're getting tighter on time. Again, the links in all of these to code. So for example, conductor and dispatcher code, those links go straight to those codes. So you can start to get a feel for what's in the repo. So now again, we're talking agent, not controller anymore. Controller, all of the links in the previous were to the controller code, and in particular, the demo Alice and Faber controller code. These are now going to the agent. So message flow inbound, this describes what happens when a message comes from another agent inbound, passes to a conductor. It associates a message with internal connection state, passes it to the dispatcher. So the dispatcher is the thing that passes it to the protocols to be processed. So it'll do some initial processing to grab the ID and thread. So it'll find out where it's intended to go, what the current state, if this is not the first message of a protocol instance. It processes other decorators as appropriate. So things like timing protocols or timing decorators, things that are cross-cutting, and then it might skip some where the protocol itself should handle those. So that was some code added recently. where not all decorators are processed in the dispatcher. Some of them are left for the protocol to handle. It then figures out what handler should be called. So within the messaging folder, the messaging contains all the protocols that are coded into ACA-Py, and within those are handlers for each message type. So those would get called. And then the dispatcher also handles the sending of outbound messages for the handlers. So if the protocol handler decides, oh, well, I am ready to process an outbound message, it would be handled at the end of the dispatcher. Make sense?
I have some questions about
Yeah.
modules and you know, passing in modules and alternate modules to the ones that are in there, or having them in parallel. I'm happy to get to them whenever is most appropriate. So if this isn't the right time, we can push them off.
Nick, what do you think? You want to handle that one now, or
Yeah,
hang on?
I can just touch on that. You're just thinking about how.
Well, let me ask specific questions.
Sure.
One is that if I wanted to add an additional module that handled a message that was already handled by an existing one, and let me just like pick basic message, for example, just as a for instance, and I wanted to, there's a couple modes I'm thinking of. One is that I would want to leave the existing module in place, but also add a handler that would receive the message and process it. The other one is that is whether we've considered disabling the internal handler for a particular family and just use the new one that we've passed in.
So I don't think we've considered that scenario yet. It would likely be possible, but like currently I believe there's several kind of built-in protocols that handle, you know, they kind of match the Aries RFCs, and then it's also extensible, so you can add your own for whatever you want. I think to answer your question, most likely what will happen is that eventually the agent will ship with almost no protocols, and you'd kind of piecemeal install what you want. And I think that would, you know, you wouldn't have to turn one off because you would only install the protocols that you are intending on using. That's likely the path that I see it taking, but if there's a use case for installing, you know, multiple handlers in a chain on the same protocol to like extend an existing protocol, we haven't considered that, but I can see it being a feature in the future.
Okay. And then, so rather than turning them off, you just imagine that you would have to, you know, include the ones that were already there, for example. You know, obviously it's got to ship with some default protocol handlers for some logical behavior, but you could, you would enable the ones that you wanted rather than disable the ones you didn't want.
Exactly, yeah. Like I think, for instance, you know, connections would always be there, but stuff that's, you know, it's like the Aries, maybe it's like the Aries Indie credential issue. That could be like a bundle of protocols that you install. Similarly, there could be UPort or so on. And I could see those being pulled out into different Python packages that you could install as you need, and then they wouldn't conflict. Or you could write your own and then handle it however you like. That's kind of how I see, you know, how I see this kind of progressing.
Okay. Thanks.
Okay. Likewise, outbound message flow. Here's the list. You know, you've got handlers. You've got the admin handlers coming in. There is a responder object which allows dispatching of outbound messages, and those would usually go to a connection ID that's already been established. Again, obviously, the connection protocol would be the exception there. Actually, the soon-to-be did exchange protocol would be the exception there. Dispatcher admin returns the outbound message, and there may be decorators, again, cross-cutting connectors, decorators that would be added at that point by the conductor. So again, example there is the timing one. So again, things that are cross-cutting to protocols. Pack the message. Big thing here, return routing is supported. So where you have an agent that has no endpoint, you can use return routing, which means that the message would be basically put into the response request of an existing inbound message and sent as a response. I shouldn't say message, I mean request. So you've got an inbound HTTP request. In the response to that HTTP request, you would pass the message as part of the return result of that HTTP request.
So
and finally, it's past the outbound transport.
On those two topics, is there do we have currently the ability to queue a message for a for an endpoint that or for an agent that doesn't have an endpoint but connects occasionally? Is that something we've gotten to yet?
Andrew?
No, there isn't a queue right now. It would just drop the message.
Okay, so that's some good future work that we can work on.
Yeah, there is a spec written for that, I believe. I'm not sure if it's in Aries RFC or it's just something you've written, Andrew. I think it's just something you've written in HackMD.
Yeah, it's just a draft.
Yeah. So we'll get that into an Aries RFC, and then that is a good candidate for implementation.
Okay, thanks.
Okay. Here's, sort of a write your own protocol. So a couple of reasons you would do that. Obviously, implement our Aries RFCs that haven't been written yet. So once they get defined, define one and implement the protocol. Or you might have your own use case, a case-specific protocol. So in Indy Catalyst is the basis for an org book. And in an org book, it's a central repository of credentials, and it has many issuers. And there's a register issue protocol that is needed. And so in the Indy Catalyst repo, we actually have this external message family protocol. We've got some requirements for it, versioning information, and then in this folder is exactly the same structure as any protocol that's in the core ACA repo. So you've got handlers, you've got messages, you've got the models necessary for it, and then you've got supporter functions for managing it, routes for it, and so on. So that is sort of our first instance at trying to see what it would look like to add our own use case specific protocol. So we do have an example of that. Basically, define the module, define and implement the module, or register the API endpoints, define the messages, define the tests for it. From a protocol versioning perspective, looks like our basic approach. So we're going through our first instance of this, which is we have the 0.1 version of Credential Exchange implemented. Stephen Klump has implemented Aries RFC 0036, which is the issue credentials one according to the Aries RFC. So we basically now have two protocols that handle Credential Exchange. And right now, we're going to just do it by having two copies of the protocol, have a deprecated version and a new version, and just basically migrate that way, rather than trying to do any sort of fancy handling of, this version is almost the same, but it's got a slight variation, and we'll code it in logic. We're just going to have multiple copies of the protocol is our thought. That we're going to learn from as we go. I don't think we're fully have it handled, but I think that's the best approach so far.
Definitely the best approach, as I've learned from painful experience.
There you go. Thanks. All right, couple more minutes. So there is a series of other things that are pluggable implementations. So inbound and outbound transports. Currently, HTTP and WebSockets are supported, but others can be added. So there's basically a base implementation. For all of these, basically, there's a base implementation, and then you can provide additional overrides that are at deploy time selected to handle that. So there is a basic wallet that is just an in-memory wallet, and then there is an Indy SDK wallet. And of course, since in the Indy SDK wallets are themselves pluggable, you can choose, if you choose the Indy SDK wallet in the agent, you can then choose, do you want to use the SQLite version or the Postgres version? So that's basically the mechanism. Wallets handle Indy entities, so things like DID schemas and cred defs. There is also a storage implementation, and that's basically for what we call non-secrets in the Indy world, which is basically anything other than these entities. So things like when you persist the state of a protocol instance, that would go into non-secret storage. When you create a connection and you have a connection ID, that goes into storage. And again, you have a couple of choices, the same choices above as for wallets.
So the other thing I'd love to mention here is that the ongoing migration between the Indy work and the Aries work will not only carry these things over to Aries, but generalize them so that they'll store, for example, non-Indy DIDs and non-Indy credential material, et cetera, as part of that process to generalize it.
Yeah.
A question here, please. I just wanted to understand if you're implementing the wallet using the SQLite or the Postgres, will the data be encrypted there as well? Like, how does it go?
Could you repeat that a little louder? I couldn't quite hear.
I just wanted to understand if I'm implementing a wallet using the SQLite or the Postgres, is the data inside that wallet also encrypted, or how does it work? Is it like, I want to understand if it's the on-chain data, or will we call it the off-chain data?
Yeah, so there's a really good Indy hype, and if you want to ping me on Rocket Chat, there's a really good description of how Indy implements a wallet and what goes into it. And how it gets encrypted, how it gets queried. So a bunch of work was done, about a year ago. So for how, what the structure of it is, how you query it, so you don't get everything out of the database, even though it's encrypted, so you can search for specific things. So there's a very good hype that explains all that, and that covers basically both of these, because ultimately, both the wallet and the storage implementation in Aries is for now using the Indy implementation of those. So that should cover that.
Okay.
Dan, you've got your hand up?
Yes, I have a question actually regarding the pluggable bits. I'm familiar with the whole wallet storage that you can basically implement your own. Is there also a mechanism to actually move the private keys somewhere else that you can have the signing actually, for instance, in hardware? That you say, okay, I offload the whole signature to some other mechanism that you can, that it's not in the software.
So the library has, they are working on HSM support for that crypto, and the goal is to build on top of Ursa's support for that. So it doesn't yet, but that's the goal.
So Ursus would be the project to look at in order to support that in Indy. So if we say, okay, we want to move the whole private key signing into HSM of sorts, that the pluggability will be actually implemented by the Ursus group.
Yes, and Mike Lauder with the Sovereign Foundation, he's heavy in the Ursa community, is the one to reach out and to coordinate with that.
Great, thanks.
So I have a little bit more. We're probably going to miss one demo that we wanted, but it's 9 o'clock, so I apologize for running over. And if anyone has to leave the recording, we'll continue to go. But I think I'll keep going, even if everyone leaves, just so we can finish this off and there can be a recording for it. So hopefully you can stick around, but we'll see. Other components that I wanted to highlight. Basically, these are all injected in the same generic way as the implementations covered here. There is an admin module, a cache module that has a basic in-memory cache that is mostly right now connection records, but can be extended to cover other things to cache. There's the configuration setup, which is where the command line and runtime configuration is managed. And finally, there is a holder and issuer verifier for the indie implementations of these types of participants. So when you go to the Aries Cloud Agent, you know, the main Aries Cloud Agent folder, these modules sort of exist. So that gave a laundry list. As I said, messaging is where all the protocols are. You know, other ones, the wallet implementation, the storage implementation are there, transport implementation, and then these other ones are the ones I've mentioned: admin, cache, holder, issuer, and verifier. So the two big things, developer concerns that, you know, big things we're trying to address. We just sort of randomly picked a few things. Choosing the right controller stack is kind of left to the developer, and that's what the intention kind of is, you know, you can use any language you want to create the controller. You use the agent, as I said, is when you're building a controller for production, you ought to be tagging using a particular tag of ACA-Py from PyPy. So you're using, you know, the 0.21 release, which is our current one, and just deploying it from there. You're not pulling in that code and building it from source. You're using the artifact from PyPy. And then you can build the controller in whatever language you want. You can use whatever web development framework. Again, largely you are handling HTTP requests, events that are coming into the controller, and then sending out HTTP requests to the agent to do something that needs to be done. So again, web development frameworks. We've had the two you're going to see that I reference in there, IIW book and the email verification service. Those are both Django apps and worked really well for that. But you can use, you know, whatever you want. And then the other thing is the legacy integration. So one of the things we've got, we're building out right now for our org book is we have an integration where we just listen to a government service that issues credentials, that issues incorporations for companies. And all we do is we listen to, we monitor the event database in that, and whenever something happens in that, we make calls to our agent to issue a credential to the org book for that. So again, we're not using any sort of web framework. We're using a integration framework that we found that is useful for that allows us just to monitor events, you know, run a process on a cron basis to monitor events when events occur. We just use the admin API of the agent to process that in a way to publish a credential over to the org book. Lots of options for what you can do with that. And basically, again, if you think of the agent just as a separate process that the controller controls, gives you a nice clean view of what you're trying to do with it. Why don't we, Nick, are you ready to do a demo of this? So there is a -- debug option that supports IDE debugging while running in Docker, and that seems to be a holdup for some. And so currently supports Visual Studio. We could use guidance on any other IDEs in that, but Nick, do you want to do that demo now, or are you ready?
Yep.
Okay. I'll stop sharing for a moment, pass it over to Nick just to have a quick look at that.
All right, so I'll just show it off quickly here. So I've got, so I'll run two agents. Just move my little Zoom bar thing, 1 sec. So two agents, they run on different ports. The important bit here is that one of the agents I'll run with --debug. So I'll run that. I'll run the second agent as well. And so the first agent, if you run it with --debug, it waits for a debugger to attach before continuing. So this is using PTBSD, which is a debugger for Visual Studio and Visual Studio Code. So if you have either of those IDEs, you can use the debug feature, and it's going to be a remote debug. So this is Visual Studio Code. So remote debugging, since it's running in a Docker container, we need to, effectively remotely attach to the debug server. And it's just using the default port number and localhost. We have the port punched through, so you can just reference localhost here. And if you just hit go, so now it's connected. You can see that this is what it looks like in Visual Studio Code. For example, I have a breakpoint in the connection manager at receive request. So I've got two agents running. If I create an invitation on the first agent and receive that same invitation on the second agent, send
And if
that.
I could highlight just for a second, Nick, if you want to switch back to that, that is the Swagger interface that you're seeing. So this is how you can be the controller. So we've got a demo of that, and you're just running a Swagger interface. So this is what gets exposed. Action menu that you see on the screen there, that is a protocol that we've implemented. It's not got an RFC associated with it. It's just one we've done locally. But that is a protocol, and that protocol exposes a bunch of endpoints that can be used. Connection is another one. And so get connections is the endpoint you call to get a list of the connections from the agent that it has. Go ahead.
Yep. Yeah. Let's see, where was I? So yes. So
sorry about that.
Fine. So the connection, right? So the create invitation, we pasted it on this side over here. This side, as part of that protocol, it sends a connection request back to the initiator, or I guess the agent that exposed that invitation. And so I've got a breakpoint here, and so it's paused here. I can inspect the state and step through and all that kind of stuff. So just as you'd expect. So this is PTBSD. A few months ago, we did play with an additional remote debug solution for, I think it's called PyDevD, which is the other remote debug server that I'm aware of. And that's used in PyCharm and IntelliJ and probably some other IDEs. So it shouldn't be too difficult to run that as well, or have that as an option, maybe --debug -PTBSD and -debug -PyDevD. But those are the two options that I'm aware of.
Cool.
I have a quick question. On the command line that you just did, I didn't see a Genesis transaction. I was wondering, what ledger is it attaching to if you don't put it in?
So in this case, the ledger isn't required. Since we're not doing any sort of, since we're not issuing any credentials in this example, the ledger actually isn't required. So it's not a requirement to run the agent. The connection protocol does not require a ledger. So it does, it's all peer-to-peer DIDs. So it's the peer DID method. So there are DIDs involved, but it's just between these two agents, and they're not publicly stored on the ledger.
Okay, that makes sense. If you did want to put that Genesis transaction, because obviously if you put the whole transaction in the command line, it's pretty long, but you could give it a path. Is that something you could do?
Yeah, so it accepts, like you said, the whole transaction, which makes more sense if you're just automatically deploying this in some sort of environment, for production. But for when you're typing it in, it's a lot easier to do --Genesis-URL, I think. And if you point to that, a website that serves that Genesis transaction file, then it'll pull it down and use that. So you can use that as well.
All right, sounds good.
And I think Stephen
Yeah,
was
so
going to
that's
go.
that's the common way we do that with, Von Network. When you use that, it exposes a Ledger browser server that also includes a /Genesis endpoint. So that's why we include URL. But there's also a Genesis file, I think, environment variable that can be used. I believe it's environment variable. But there's a series of ways. And that's one of the clarifications we want to get into the documentation. The demo, I think, should be clear pretty soon as to, if you're running locally, how to do that. In the Docker and play with Docker images, it's more or less automatic how it gets handled. And it just finds the ledger using techniques, known predefined techniques in the demos themselves. Jan, I think you have a question.
I actually want to know if the API itself is also part of the standard, or is it just the payload?
So the API there is no standard. It's just it's what we've created for the agent. So any communication between two agents that is standardized, but we've created an API between the controller and the agent, which at this time it's just a bespoke API that we use just for this agent.
Thanks.
Okay, next one, Sakal.
Hey, hi, Stephen.
Hey, how you doing?
I'm doing good. So just want to ask, so the webhooks that are exposed in the Swagger API, I see that for the wallet, right, there are only two webhooks that are, or one webhook that is exposed, that is the Cloud Agent verification key, if I'm not wrong, or there are no wallet webhooks that are exposed. So if I want to create a public DID, right, how do I do that? Do I write my own webhook, or is there any parameter that I pass?
So to create a
Andrew, Nick, good.
Yeah, a public DID, and this may have changed just in the last couple of days, but previously you would do --seed, and Andrew, you can jump in if this is different now, but --seed here, what we were using, and this basically is the seed value that creates a DID, and then this DID will be made public. Andrew, do you want to comment on that as well?
Yeah, so there's that seed method will still be available, but I am looking at adding some DID management API endpoints as kind of my next task. There's an issue filed on the Aries Cloud Agent Python repo for that. DID provisioning methods, I think it's called.
Okay.
The other part of that is there's a separate provision command, so you can provision the wallet ahead of time.
Okay.
Yeah, and that's what we're working on with this idea of separating out the command line invocation. So you have a series of wallet commands, you have a series of run commands, or a series of parameters associated with the run. So you can construct scripts and invoke things in different ways for different purposes, especially for a production environment.
And just to answer your question, I think right now the best way to get the DID, the public DID, if you use the seed parameter and just pass in any 32 byte string, and then, oops, this is old, 1 sec.
You're not sharing anymore.
I'm not sharing anymore. Okay, one sec. Or you kicked me off?
I did. Sorry about that.
No, it's okay. So if you run with a seed parameter, the startup information that's printed to the console when you run it, it has some information there, like the endpoints that you're exposing the admin API on and the transports on and whatnot. One of the things that it exposes is the DID, the public DID. And so use the --seed for that, and then it'll, so there it is right there, actually, Stephen, that public DID. And again, that's probably not the most ideal way to do this, and we're evolving and looking at improving that. But if you need a DID that's that's the best way to get it, I think, right now.
Got it. Thank you.
Cool. Steve, you had a question.
Yeah, following up on the PTVSD. So I think you said that you've got that set up to run the Docker container. Is that right?
That's right. Yep.
And is that off of ACA-Py, or is that just off of the GitHub code?
The PTVSD, I believe, is a development requirement. So it installs PTVSD from PyPy, if that's what you're referring to.
Yeah, so I haven't been able to download PyPy yet, so I'm just off the GitHub, and I see you've got the Docker containers there. I didn't know whether it's on PyPy as well. And then where do you have your breakpoint? Where's the wait for attach?
That was in Connections Manager.
Connections.
So so inside of the messaging directory, that's all of the different protocols.
Mm-hmm.
And I was looking in the Connections protocol, and then most, or not most, but I guess depending on the use case, a protocol will include a manager module and class, and then in that manager class there, one of the methods was called receive request, and that's where my breakpoint was.
So I think what we'll do is I'll get Nick to do a recording, a Zoom recording of like end-to-end setting up a debugging session. So in more detail than that, and then we'll turn that into a demo that we add to the site, because I think that would be a really helpful thing for everybody.
Yeah, for sure. And Steve, I think I understand your question a bit better now. If you install ACA-Py via PyPy, that does not include the development dependencies, which we split out. So in that case, that code would not include PTVSD. So you would want to run it from the repo.
Mm-hmm.
And I think if you use the Docker run script, that'll automatically install that and make sure that's available.
Yeah, that's good. And just to clarify, there's like 3 or 4 lines of code you put in order to be able to attach the debugger, right? To enable detach and wait for attach. Mm-hmm. I don't think that was in the connection module. That was in something else though, right? Or was that in the connection module?
Yeah, the couple lines of code just to attach. That's in the ACA-Py module in the bin folder. So that's Great. Essentially what's installed to.
Yeah, thanks.
Okay.
Okay. Actually, so a bunch of the demos, we use a thing called Play with Docker. We actually have our own instance we call Play with Fawn. So you'll see in the demos, this is the environment you use, and it gives you a really nice, easy way to, run a quick command, git clones the thing, cd into the directory, and then just run the command, and allows you to run these demos really easily for a first cut in just your browser. So just showing that as a quick example of what we're using. Should be basically done now. Other topics, routing, we won't go into that, but basically the performance demo is now documented in the demo README, the demo folder README of how to run it in routing mode, where you're actually spinning up 3 agents to run this exchange of 300 credentials. And you get timing, and you'll see how long each agent processes it. You'll see that the routing agent doesn't take all that long. And I think that's all we have. Certainly over. I apologize for that. Are there any final questions before we wrap it up?
Actually, I have a question. Related to this routing node. Is it somehow similar to the libvcx dummy cloud agency?
I don't know. Okay. Anyone want to handle that one?
I may not be the best person. There's certainly overlaps, and they seek to serve some of the similar goals, but from fairly different approaches. It is worth noting that this is current with the state of protocol design in the community that we've been pursuing, and libvcx is not yet.
Okay. Okay.
Yeah, this is 0092, I believe, is the routing RFC, but I could be wrong on that. But there is a routing mode where you're passing your messages through it, and as inbound messages come in, they come to the routing agent, and they can't read them, but they can just pass them on to you.
So the dummy agent in libvcx performs that level of routing, but I don't believe it uses the same. It uses the currently standard community routing RFCs. I know they're working on getting it there, but it's not quite yet. And then the other aspects of libvcx also overlap with other elements of this project, but it's not a perfect one-to-one match.
Okay, thanks.
All right, with that, my AirPods just gave me that quiet little, you're almost running out of power sound, so we must be done. So thank you all for attending, and I'll get the recording of this done and get Sam's help to figure out how to post it and get it in a place people can find it. So that's it. Thanks all.
Thank you, Steven.
Thanks.
Thanks.
Thanks. Thank you, Stephen.
Bye.
Bye.
Cheers. Thanks.